Welcome everybody to Azure Serverless Conf. I'm super excited to be here and talk about how you can build a auto-scaling-over-time dashboard with Azure Functions and durable entities. My name is Tom Kerkhoven and I'm an Azure architect for a company called Codit. And you can find me on GitHub, on Twitter if you want to follow along. I've maintained various projects such as Keda, Prometheus, and others. If you are interested, don't hesitate to reach out or stay on top of what I do on my blog. But the topic of today is auto-scaling. But what is auto-scaling really? If you ask people, they typically give you this answer. It's the act of adding and removing instances to meet the demand of your platform and to be able to cope with the load in a cost-efficient way. However, if you have a look at the full picture, there's more to it than you think. You should also monitor all your scaling actions to see if your auto-scaling criteria is working correctly or if you have auto-scaling loops. You should also be able to understand how many instances are you running at a given point in time. Certainly when you're doing analysis of incidents, this is super essential. And you also want to get the most out of your budget, so you want to have those budget alerts. So auto-scaling is really a continuous improvement process that you need to use to align with your platform needs, because it will change. So it's up to you to stay ahead of it and make sure you know what you should be doing. Now, if you have a look at auto-scaling on Azure in general, there are various auto-scalers or ways to scale your application out there. Just to name some examples, you can use serverless technology, what we will be talking about today. You can use Azure Monitor Autoscale, which is somewhat of a good example of a good autoscaler. You can autoscale Cosmos DB. You can also use a cluster autoscaler for Kubernetes, Keda for Kubernetes workloads, Bellhop for time-based autoscaling, and there are a lot more of them. Now, this is out of scope for this presentation, but if you're interested, there's a website that starts listing all of these and help you use the most out of them. But the gist of it is there is no common ground on all of these approaches. So it is up to you to define and build a centralized auto-scaling strategy for your platform if you use multiple autoscalers. This is somewhat of a tricky point. Because they all have their own way of scaling, how they work, and also the insights that they provide to you. In order to do that, that centralized strategy really helps you, and you will have to get your hands dirty to meet your needs, because Azure can only give you the tools, but it will not always be tailored to your needs. But that's where Azure Serverless really comes in. It's an easy way to build this tooling in a cost-efficient way without having to worry much about the infrastructure. Now, before we move on, some autoscalers will not allow you to integrate because the insights they give you are very minimal, but for the majority of them, you will be able to do this. Now, in this example, I will use Kubernetes workloads and workloads that you can scale with Azure Monitor Autoscale, where the idea is that you use Azure Event Grid as your centralized hub for all things autoscaling. So all your autoscalers will emit events to Azure Event Grid, and then you can basically extend them and use those events how you need to. For example, at the top right, you see that we can subscribe to scaling events, and then we can post messages in Teams so that your development team, operational team can get ahead of it and see how the scaling is going on. If you scale from one instance to your maximum instance count in 5 minutes, I'm pretty sure you have either a big business or a big problem on your auto-scaling criteria. So you want to verify these. Then in terms of the auto-scaling dashboard, which we will go more into depth today, you can just have an Azure function that takes these events, interpret the new instance count, and write them as a metric so you can visualize them. So as you can see, you can just use these serverless technologies to take the information that is available and use them how you need to use them and make it super user-friendly for your colleagues. Now, if we just write the metric for every event, which is the most simple approach, you will see all your application instances in a scatter plot. Here you can see all the application instances across 2 days in September, where the average over the whole period was 5 seconds, but you can see the majority is 1. If you provide multiple dimensions to your metrics in Azure Monitor, you can even split them. So in this case, you now have more insights and see that my reverse proxy was at 5 instances, while my APIs were at 5, 2, and 1. So you get a better understanding of your landscape. Now, the problem is, if there are no scaling actions, you will see no dots, because we only report the new instance count when the scaling action is happening. So how do you know how many instances you had at this time? Well, you don't. You have to go back in time, find the last dot for the application that you want, and then you understand how many instances you had. But if you haven't scaled for 1 month, you will not be able to, well, you could be able to find them, but you'll have to go back a long, long time. So this is not really ideal, because what we were doing is we're actually visualizing the auto-scaling events and not the instances over time. This is not a bad thing per se. It is a first step in visualizing things, but it's not really ideal. Instead, we want to have a nice graph showing the current instance count for every application in your landscape. So let's just fix it. So this is where Azure Functions and Durable Entities come into play. We will use Durable Entities to keep track of the state of our application instances and make sure that the metric is always available for us, so that we really have a nice auto-scaling over time experience. Edit. I know it's not the goal, but this is not the slide that I needed. Fuck. Okay, I'll just continue from this one. Nothing happened. So before we talk about durable entities, let's just have a look at what Azure Functions leverages. So the traditional Azure Functions are stateless functions where you can use the bindings to really build serverless applications. Now, Azure Functions also has 2 different flavors of functions, which you can mix and match with the traditional Azure Functions. First of all, we have durable functions, which are stateful, and they are typically used for doing orchestrations of activities such as chaining functions, doing fan out, fan in, monitor scenarios, and more. Second, you have durable entities who are also stateful, who also rely on the durable task framework, which is open source as well, but it is more of an actor-like pattern. I will only focus on the last part, but do note that you can combine all of these 3 types of Azure Functions together, depending on your scenario. So what is a durable entity? A durable entity is a stateful representation of your business model. I've mentioned it in the previous slide, but it is somewhat of a virtual actor, and it can be anything that makes sense to your business. For example, it can represent a customer, a warehouse, or in our application, it will represent the application and its state around the instances. Where is it deployed? What is the name? And what is the runtime? For every instance of our application, we will have a unique identifier so that every application has its own state. So in theory, the unique identifier is your partition key for your state. If you're using customers, that would be the customer ID. In our case, that will be the application name and the runtime. Now, the beauty of this is that the state is fully managed for you, and you don't have to worry about that. I don't have to store it in SQL and read it again or use another data store. No, Azure Functions does this for me. Out of the box, this uses Azure Storage, so I don't have to worry about this. I just interact with my durable entity, and it gets persisted correspondingly. If we have a look at one of the default examples, they use a counter, where the counter is the class, and every property of the class is serialized as state by default. So in this case, the current value property is going to be stored as state with the name value. And then I have 3 operations that I can call on the entity, and then the trigger for this durable entity. So that means from a client perspective, I can interact with the methods, just like it would be any counter. I can set the properties, but the state of it will be managed by durable entities. So it is a very simple approach. Also for modeling entities, but if you have a look at the consumer side, it's also fairly straightforward. So in a typical Azure function, what you can do is you can add a durable orchestration context as the input and the orchestration trigger. Then next, what we do is we create an entity ID, which is the name of the entity and the unique identifier. Then we use the entity proxy to create an instance, and then we just use the operations of that entity to interact with it. So we can increment the counter, and we get the counter value, and we can return it. So it's super simple. Now, if we have a look at our scenario, what we will do is we use still the Azure function, which is a durable entity, one specific for Kubernetes. And we also have one available for Azure Monitor, which is the more generic approach, because they have tailored metadata. In the Kubernetes approach, we will have an application name, a namespace, and the current instance count. And then we will use that state and have a second function so that every 5 minutes we read the state and write the metric again to create that constant graph. If you're interested, this sample is available on GitHub. So if you go to github.com/tomkarkove/autoscaling-over-time dashboard, you can just fork it, make your own changes, or simply deploy this to your Azure subscription and get going. And if we do this, we will have this nice chart showing the full instance count over time. But talk is cheap, so let's go to a demo and I can walk you through it. So if I go to the Azure portal, this is the end result that we will have. So we have a chart here where I have the full instance count of my Azure landscape. But because I provide contextual information, I can also say, hey, show me the instance count per application. And here I can see that my order processor on the top left is now running at 1 instance, and it was scaled to 15. And it was then scaled all the way back. Now, if I want to see it per runtime, I can also see that the majority of our applications are running on Kubernetes, and it has 25 instances running, while on app service, I have 6 instances running. Also, if I go to the Kubernetes side, I can see the instance count per namespace. For example, the majority of the instances were running on the KDA namespace, and then I had the cron scheduled workload coming in second. If I would go through the chart, I would see that the KDA demos is actually scaled down to 1 fairly often, but here we had a big spike. Whoops. And then it went back to 1. And this is all by just writing one metric for every application every 5 minutes. And since we're using a dashboard, we can also use this contextual information and say, hey, instead of showing the information for all of them, let's just go with the order information. And that dashboard will adapt correspondingly. And you can see that I have that information at my fingertips a lot simpler now, straight to what I need during the troubleshooting that I'm doing. Now, how does it work? I have here an Azure function, which is called Azure Autoscaling Toolbox. It has some functions in here. If you have a look, you can see I have two durable entities. So I have a generic one, which represents the Azure Monitor approach, which has more state than the Kubernetes one. Then I have a various HTTP triggers. So one in case Azure Monitor has scaled, and one in case a Kubernetes application has scaled. So this is the scale notification coming in through Event Grid. Then I have two other HTTP functions to read the state back in case we want to create a dashboard or allow people to integrate with it to read the state. And then I have two timer triggers, which will basically report all the instance counts every 5 minutes, which is configurable. And then on my event grid topic, which receive all the platform events, I just have a subscription here, which is called Azure Autoscale Toolbox, Stateful App Scaled, which is just forwarding all the events to my HTTP-based Azure function. So how does it work? In this HTTP-based trigger for my scaling notifications for Kubernetes, I have the HTTP trigger. Here I have the authentication handshake for Azure Functions, for Azure Event Grid to ensure that I own this function. I parse the event payload into the type that I know I'm expecting. I do some input validation, and then this is where the magic happens. So to interact with my durable entity, all I have to do is create the entity ID. Then I use the durable entity client, and then I signal the entity, which means I want to call a method on that entity, which is defined in this interface, and it is called scale, where I provide the new replica count. So from a function perspective, it's just simple. I define the unique identifier and I call a method on it. If we then have a look at that interface, it just describes those methods that are available to be called, which are implemented in my durable entity class here, where I have three properties and just three state fields. What is the current instance count? What is the deployment name? And what is the namespace? Now, in this case, the entity ID, so the unique identifier, is a representation of both the deployment name and the namespace, because that's the unique identifier in Kubernetes. I can create a deployment with the same name in multiple namespaces, so I need a combination of them to have the unique state. Now, if I call the scale method, which is the new instance count, I do three things. One is I report the scaling action. I set the new state with the new instance count, and I report the count. So reporting the scaling action, all it does is I track a business event in Application Insights. And then once I want to report the instance count, all I do is call log metric, where I have the metric name, I have the new instance count, and the contextual information. And you can already see it. The contextual information is just a dictionary with the application name, the namespace, and the runtimes, which give you the dimensions that we saw. So creating a durable entity is super simple. You create a class. You have properties that represent your state, and you provide the methods to interact with. Now, to make the circle full, I need to report the metric every 5 minutes. So what happens is I will use a query on the durable entity client, list entities async, where I basically say, give me all the instances for the entities with the name, and then this is the name of my Kubernetes entity. This will give me all the instances that I can call, and then I will issue and I will signal the entities to run the report current instance count method, which just logs the same value again, which creates that view. And just to show, if I clear this and change this chart from an area chart back to a scatter plot, you also see that we still have all these dots being reported, but because we give the additional dots, the chart is becoming a really fluent line instead of just the individual scaling events that we saw earlier. Now, if you deploy this will work fine, and you will have the chart until something goes wrong. So you also need to monitor your durable entities, and if you use durable functions, you can use the same tool. But the durable functions monitor is an open source UI that you can put on top of your Azure Functions that will visualize all your state, what the status is, and interact with all your durable resources. It's available on github.com/scaleton/durable functions monitor. I highly recommend deploying this with all your durable applications because it is super simple to use and it makes the operational side a lot easier. Now, to wrap up, I highly recommend you to design a centralized auto-scaling strategy and use Azure Event Grid and Azure Serverless to come with the best solution and also the most cost-efficient one. Make sure to have that auto-scaling dashboard to understand what your instances were doing over time. It will save you when you have production incidents and you want to better understand what was going on. You don't have to build some advanced things. You can start really agile and have just the scaling events, and then over time at the auto-scaling over time with stateful and durable entities, but just make sure you have something. ChatOps can also help you understand when you are scaling and identify if it is what you expect or you have some misconfigured auto-scaling rules. And if you want to use a stateful auto-scaling dashboard, durable entities are really a great way. It is a serverless actor-like way to run these workloads on Azure. If you use Kubernetes, you can also use Dapper, which is a great alternative. With the same concepts, just some different APIs, and you can get started. Lastly, don't forget about Azure Monitoring and use Durable Functions Monitor to have that monitor layer on top of your durable entities. All it does is it uses the same storage layer, but puts a nice UI on top of it for you to better understand what is going on. So hopefully you've seen how durable entities is super simple to use and how you can implement this in your own applications. Thank you for watching and see you next time.